Hello again everyone, and let's get to a few questions in organic chemistry. These are just a few practice questions for JAM and other type of GATE exams and different competitive level exams. So in the first question we can see that we have to brominate a toluene compound in the meta position. So for solving this question, what we'll do is that firstly we will be using nitration reaction. So constant H2 and constant H2O4 gives us the nitro in the ortho position and the para position. So let us say that the nitro is in the ortho position, and let us say the nitro is in the para position, and we isolate that product. Then what happens is that after the nitro is in the para position, tin HCl actually reduces the nitro to the corresponding amino group, and after that what happens is that the amino group is acetylated with CH3CO whole twice O, so creating the NHCOCH3 or the acetylene, and there is also the methyl group. After that, electrophilic bromination is performed via TIFR, where bromine actually incorporates itself ortho to the NHCOCH3 group, which is the predominant directing group here. So the bromination happens at the ortho of NHCOCH3. After subsequent hydrolysis, what we get is that the NHCOCH3 group converts to the NH2. After that, we produce the deamination sequence. We do the deamination sequence. So first we diazotize the NH2 to N2 plus Cl minus, and after that the diazonium compound is treated with H3PO2, which actually removes the diazonium group. So this is actually known as the deamination sequence of reactions, and hence we get our product. Going to the second question, we have to convert this toluene compound once again, and from toluene we have to make it a trinitro benzene compound. So for affording this conversion, first what we will do is we will do an exhaustive nitration with fused HNO3 and fused H2SO4, and such type of exhaustive or excess nitration, what happens is that a trinitro substitution takes place in the toluene ring. After the trinitro substitution, we will oxidize the CH3 group, that is the alkyl or the methyl group in this case, into the COOH, the corresponding carboxylic acid. We can also use cheminophore in this step for this oxidation. Anyways, so CH3 converts to COOH, which on the application of base, the COOH being the acidic compound becomes COO minus. And after that, our arrow pushing mechanism shows us that how the decarboxylation takes place. This happens because due to the presence of three NO2 groups, which are electron withdrawing groups, the minus charge is stabilized over the benzene ring. After that, the base which was protonated gives back the proton, and hence the benzene ring, the phenyl ring again becomes protonated, and we get our trinitro compound. So this is known as the basic decarboxylation actually. So decarboxylation happens. Hence, this is the reaction. Let's go to the third question. So in the third question we have to convert the benzene to benzene to orthonitroaniline. So this is also a pretty interesting reaction sequence. So first we will actually nitrate the benzene ring. So nitration happens. So NO2 group incorporates. After that we reduce the incorporated NO2 to NH2 using tin HCl. And once this aniline is obtained, we actually acetylate it using CH3CO whole twice O, which is the acidic anhydride. We get the NHCOCH3, which when used with H2SO4 gives us the sulfonic group in the para position of NHCOCH3, NHCOCH3 directing the SO3H or the sulfonic acid group to the para position. After that, we do nitration to this compound, and what happens is that electrophilic nitration, the nitro group is actually entering in the ortho position of NHCOCH3, which is actually ortho directing. Subsequent hydrolysis gives us NH2 from NHCOCH3. After that, we do the desulfonation reaction, where once again by the application of H2SO4 and water, SO3H is removed, and we get our product, which is the orthonitroaniline. Okay, so we are going into the fourth question. Let us check the question first, the fourth question. So in the fourth question, there is another conversion that is taking place, where we have been given actually an benzene ring with an acyl functional moiety over the benzene ring, and this we have to convert into the metanitro derivative of the corresponding alkyl. So it is not the acyl anymore, it is alkyl, and we have to make the meta-nitro derivative. So as we know, all acyl groups actually deactivate the benzene ring and hence are meta-directing in nature. So if we just do direct nitration of this benzene ring containing the acylated functional group, we get the meta-nitro derivative of this compound, and then we can just do a Clemmensen reduction, which is the application of zinc amalgam with mercury and HCl, and this actually reduces the C double bond O to the CH2. So the second step is the Clemmensen reduction step, and with that we actually get our product. So this is actually a pretty easy reaction in regards to the other ones. Okay, so going into the fifth question. So the fifth question is actually a pretty interesting one, where we have to justify a statement. So let us check the statement first. So the statement suggests that pyrrole is more reactive to electrophilic, at the electrophiles. Pyrrole is more reactive to electrophiles at the 2 rather than the 3 position. Whereas the opposite thing happens, or the opposite thing holds for indole. So let us check for pyrrole. Let us check the 2 substitution first. So if there is substitution at the 2 position, then what happens for pyrrole is that let's say in the 2 position we have a substitution by an electrophile which is E. So then there is H, there is E, and there is a positive charge at the 3 position because the 2 position is getting electrophilic substitution. So after that, as you can see that the delocalization which is taking place actually takes place over 3 centers. So there are 3 canonical structures which can stabilize the positive charge, and the positive charge is actually delocalized over 3 centers. Now if the substitution takes place at the 3rd position in pyrrole, then let us see what happens. So we can see that the positive charge has been forming, and the positive charge is actually delocalized over only 2 positions, 2 centers. So there are only 2 structures which contribute to the canonical form. So as you can see, for 2 substitution, positive charge delocalized over 3 centers. For 3 substitution, positive charge delocalized over 2 centers. This actually, it will not be 3 centers, it will be 2 centers. Yeah. So hence, as you can see that for indole, the 2 substitution, for pyrrole, the 2 substitution is actually more predominated, and 3 substitution is not, because the 2 substitution is more stable. Okay, so that is the transition state in the 2 substitution for pyrrole is more stable. So let us check for indole. If there is 2 substitution, as you can see what type of product we get, and we can see that the aromatic system is disrupted. So the benzenoid aromatic system is disrupted. But if we check out the 3 substitution, then we can see that the benzenoid aromatic system is intact in nature after the electrophilic substitution in the transition state. And due to this fact that the transition state, the aromaticity is not lost in case of 3 substitution, whereas in the transition state of 2 substitution, the aromatic system is disrupted. So for indole, the 2 substitution is less favored and 3 substitution is more favored. Okay. So now going into the next question. This is also a very interesting question. So iodine is actually a catalyst. Iodine acts as a catalyst for electrophilic bromination reaction, or the aromatic bromination reaction. So we have to understand, or we have to answer why that is. So let's see, if iodine is reacting with bromine in a catalytic manner, what happens? We get a species which is IBr, 2IBr. So then when the electrophilic bromination reaction takes place, as you can see by the approaching mechanism, we actually get the electrophilically substituted bromine benzene compound, and we get IBr2 minus. So this sigma positive charge complex of Br substituted bromine, benzene, and IBr2 minus, this type of ion pair actually drives the reaction. It provides the driving force of the reaction, and hence such an ion pair formation actually catalyzes the reaction. Okay. So let's go to the 7th question. So as you can see, this question is also a reaction question. So here we have been given with this phthalimide type of compound, and we have been given NaOH and Br2, and also acidic media next, H3O plus. So we have to understand first that what type of reaction is happening. So firstly we have the base present, NaOH. which actually opens up the phthalimide type of ring. And what happens here is that we get the COO minus and the corresponding amide CONH2. Now NaOH slash Br2 forms the NaOBr, which is actually a reagent for the Hofmann bromamide degradation that converts the amide compound CONH2 to NH2, the amine. Hence we get from Hofmann bromamide degradation NH2, CONH2 to NH2, and after that H3O plus actually gives us the anthranylic acid COH NH2. So this is actually the major product that is formed in this reaction. So this reaction is also a very important reaction for exams like GATE. Okay, so coming into the next question, which is the 8th question, we actually get this type of rearrangement that is happening, and we have been asked that what is the name of this rearrangement, and we have to provide a probable mechanism for this reaction. So as you can understand, this is a very well known rearrangement, which is known as the Beckmann rearrangement. This takes place in acidic media because we need the OH to form a good leaving group. So let us check the acidic media that is happening here. So first, if we take the the reactant of the reaction, in acidic media we actually get the NOH2 plus, protonation happens. After that, phenyl group migrates and nitrogen puts its electron there. So we actually get the product as such. So here the migration of the phenyl group happens because it is actually more electron rich in nature and also has got better migratory aptitude than methyl. So after that, as you can see, MEC triple bond N plus pH forms where the H2O then attacks, and after that with proton exchange we get the corresponding OHN, and which again undergoes tautomerism, and this actually gives us the actual amide type of compound MECONH-pH. So this is the answer. Okay, so going to the next question, which is the 9th question, we actually see this is actually a pretty easy question where there is an alpha halo carbonyl group reacting with NaOMe. So this is actually an example of the Favorsky rearrangement. So in the Favorsky rearrangement, what happens is that in the first step, the methoxide acts as a base which takes away the acidic proton alpha to the C double bond O. And then what happens is the enolate forms, which actually undergoes a rearrangement and kicks away the Cl minus from the group, forming a 3-membered cyclic ring there. After that, the MeO minus attacks the carbonyl compound, carbon, and forms the tetrahedral intermediate. The tetrahedral intermediate then opens the ring that was formed, and alcohol acts as the proton donor, and this actually ultimately contracts the 6-membered ring to form a 5-membered ring and an ester. So this is the the ring contraction takes place in this type of reaction, and hence this is the major product for this type of reaction. So this is known as the Favorsky rearrangement, as you all know. Okay, so going to the 10th question, this is also a pretty easy question. This is an oxidation question in organic chemistry, oxidation reaction in organic chemistry. So we have been asked that if chromium trioxide, which is Cr6O, actually is reacted with quinoline, then what happens? So what happens is that in quinoline, the benzene part of the ring actually breaks and forms 2COOH by the application of CrO3 via oxidation of the benzene ring. After that, there is heat is provided, which forms decarboxylation. So one of the COH group is kicked out, the third position COH group remains, and this is the answer. Yeah. Okay, so thank you all, keep practicing. So such type of videos will be given in more numbers, so follow and subscribe so that you get the notification. Thank you.